Okay, so as in the last video, we have discussed about the characteristics or properties of canal, which were also known as positive rays. In today's video, we are going to study the discovery of neutron, which was basically done by James Chadwick in 1932. But the clue of this particle was given by Rutherford, right? So what we are going to study today, here we have our topic, neutron discovery, right? And the clue of this neutron was given by Rutherford, or we can say Rutherford had given the clue of this particle, or he has printed out the clue of this particle. What he did, how did he find this clue, right? So for example, we know that helium is made up of two protons, right? So wait, here I have helium, and we know that helium atom is made up of two protons, right? Two positive charges. If I am taking hydrogen, we know that hydrogen is made up of only one proton, right? We know that hydrogen is made up of only one proton. Let me write this as well. Made up of only one proton. Now what did he saw? He saw that helium is made up of two protons, right? Let me make the helium nucleus here, helium atom here basically. So here I have helium nucleus in which I have two positive charge, and these are neutrons, right? Here we were not known what are these particles. These are just particles. I don't know what these particles are, right? So I'm making these particles with these blue color because I'm not sure what these particles are right now, because since they were not discovered yet, right? And there were two electrons. So this was the helium's atom. But as compared to helium, we have hydrogen atom as well, and hydrogen atom has one proton, and it has, of course, I don't know what inside the nucleus is right now, since hydrogen has no any neutron, but I still don't know what I have inside the nucleus. I just know this, that I have proton inside the nucleus, right? So I'm just gonna make here the electron as well. This is one electron, right? So one proton, one electron. Now he said if helium has two protons, then I should take two hydrogen atoms, right? If I'm going to take two hydrogen atoms, there would be two protons, right? I would have two protons. Now see, one I have this proton and other I have this proton. So now he has two protons since he took two hydrogen atoms, right? Hydrogen atoms. Now see, this has two protons as well, and this helium atom has two protons as well. Now if I am comparing this on the mass scale, right? Let me make the mass scale so that I can explain you guys. Here I have mass scale. This is not straight at all. I guess this is fine. This is fine. Here he took two hydrogens, since two hydrogens have two atoms as well, right? So here he has taken two hydrogens, and here he has taken one helium atom, because one helium has also two protons, right? So he has taken two hydrogen atoms and one helium atom. What did he saw? He has taken two like hydrogen atom, and it has two positive charges, right? Two protons. It has two protons. This has two protons as well. Now this mass machine should not go up or down, right? Since these both are balanced, two protons I have on my left hand side as well in the hydrogen 2 atoms, and two protons I have on my right hand side as well in the helium atom. So this should not go anywhere, but instead what happened here was, here I'm making the again, sorry, wait, let me make the chart here again. One helium, two hydrogen atoms, right? So instead this should not have gone somewhere, right? Because these both were balanced. Hydrogen 2 atoms were having 2 protons as well, and helium atom was having 2 protons as well. But instead what happened here, helium goes down since there was mass higher than hydrogen, right? So helium's mass was higher than hydrogen. This was the clue which was printed by Rutherford. He said, if I have taken 2 hydrogen atoms and it has 2 protons, and I have taken 1 helium atom, it has also 2 protons. Why it has gone down? Means there is something inside the atom as well. There are electrons. We know that electrons were discovered by the J.J. Thomson. Protons were discovered by Goldstein, right? But there are some other particles as well. Because of those particles, helium is going down. Because we have taken everything balanced, but still helium atom is going down. Means there is something else in the atom as well. So let me write this here now. Where is, okay, so I don't know where I'm writing. Okay, I'm writing this with pen, right? Let me write with white color. There is something there's something else in an atom as well. No, he did not tell what was inside the atom. Were there neutrons and these were, you know what, these were neutral. He was not known about anything. He just got a clue. He just printed out a clue that there is something else in an atom as well, except for the protons and electrons. Then the further study was done by James Chadwick in 1930, right? So let me write that. It is very important. It is very important, right? I don't know where to write. I'm not getting my pen actually. It's okay. Let me write with pen. In 1932, right? James Chadwick, he is a scientist who discovered the neutron, right? Chadwick, but the clue was printed by Rutherford. James Chadwick, he performed what? He performed some nuclear reactions, right? Nuclear reaction. Now what nuclear reaction did he perform? I am gonna tell you the equation of that as well, right? And he discovered, what did he discovered? He discovered an electrically neutral particle. I am gonna tell you how this is electrically neutral, right? Electrically neutral particle. Right? So he proved that these particles were present in the nucleus of an atom. I'm going to tell you that as well. These were given the name neutron. He was awarded a Nobel Prize for this discovery as well, right? So let me write this here as well. he was awarded Nobel Prize to. Awarded Nobel Prize to for the neutron discovery. Now see, in 1932, James Chadwick performed some nuclear reaction. Now he did not take the discharge tube, since those two particles were discovered in the discharge tube, Crookes tube, or you can say Kaiser tube. But he did something very unique. What did he do? He took nuclear reactions, right? And he discovered the particles which were electrically neutral, right? Now let me tell you the equation which he did, like that was a nuclear reaction, right? So let me write this here. This bit, okay, no worries. Okay, I'm gonna write this here, the nuclear reaction with this color, right? So now what did he do, right? He took alpha particle. And we know that alpha particle has double positive charge. Let me check if I can write. No, I can write. Okay, so alpha particle has double positive charge. This is alpha particle. Here I'm telling what things did he take, then I'm gonna explain you the equation as well. Alpha particle which has double positive charge, right? Double positive charge, and this is also known as helium nucleus, right? This is also known as helium nucleus, because we know that in helium nucleus what we have is 2 proton and 2 neutron. Neutron have no charge and proton have 2 positive charge, right? So this is helium nucleus, since this is 2 positive charge as well. And what else did he take? He took beryllium. Beryllium is a metal, right? He took beryllium. He took beryllium which has atomic number 4, which means it has proton of 4 number and 4 electrons as well, and it has mass of 9, right? Mass of 9. He took beryllium, which is the metal, right? This is the metal, right? Now let's do the reaction. What was happened in the reaction, right? Wait, this is a bit hacked. Okay, let me write the reaction here. Nuclear reaction. So as I told you, he took alpha particle, and I can also write here that alpha particle is helium, right? So what did he take? He took helium. Wait, instead of writing alpha particle, I am directly writing helium, right? So here I have helium, which has atomic number of 2 and 4 atomic mass, right? 4 atomic mass, and you know what, 2 is the atomic number. Plus what else did he take? He took beryllium. Which has atomic number of 4 and mass number of 9, right? When he reacted these both, right, what was produced in the result was authentic. And here it was nuclear reaction. Let me write a bit. Nuclear reaction, right? What was produced in his result was carbon, with 6 atomic number and 12 atomic mass, and there was something else as well. Now how this carbon is produced, let's check that first. As you can see, two you know what, wait, as you can see, so 2 plus 4, these are basically charges, right? 4 are the protons in the beryllium and 2 are the protons in the helium. These are what? These are charges, or you can say atomic number. Atomic numbers, right? So when you add these both, you get 6, right? 2 plus 4 gives you the number of 6. And here in the downside you can see you've got 6. Means electrons are fine. This was the number of electron, right? 2 electrons were in the helium and 2 electrons were in the beryllium, right? And here we had 6 electrons in the carbon. Electrons in carbon atom. Means electrons were balanced, but what happened to the mass, right? Here I have 4 plus 9, right? I have here is let me take white color. Okay, 4 plus 9, I know that it is 13. We know that 4 plus 9 is 13. But instead we got 12. We got 12 because one particle wasn't absorbed, right? One particle. Okay, I'm going to write with white, then I'll gonna highlight this. One particle wasn't absorbed. One particle wasn't absorbed. Let me highlight this. See, 9 plus, as I told you, 9 plus 4 must be 13, but instead we got here was 12. Means one particle was remaining. So there was something discovered with the carbon as well, and that was on that particle the charge was of course 0, since we know that 2 plus 4 is 6 and 6 was the atomic number of carbon which we have got. Means there is 0 charge on the neutron, but there was 1 remaining, right? Because we know that 4 plus 9 is 13, but instead we got 12. Means one particle was there which was not absorbed. So there was something produced with the carbon atom who has no any charge, but it has 1 mass, right? And that particle James Chadwick named as neutron. Here we have completed the discovery of neutron as well. So in the next video, now we are gonna study the properties of the neutron, right?